Hi, Math Stars. Today we're going to be doing long and synthetic division of polynomials. So this first screen, we're not going to do these problems, but these are examples of adding, subtracting, and multiplying polynomials. We've learned those things earlier this year. Today is probably the first time that you've divided polynomials. So we're going to first learn long division of polynomials. It's very similar to long division of numbers. So let's go ahead and complete this long division problem just to recall the steps. So we're first going to divide 7 into 57. How many times can we divide 7 into 57? Well, 8 times, because 8 times 7 is 56. Let's subtract here, and we get a 1. We're going to carry this next 1 down and get 11. How many times does 7 go into 11? Well, only one time. Multiplying, subtracting. Let's bring down the 3. How many times does 7 go into 43? 6 times. 6 times 7 is 42. We subtract and we have a remainder of 1. A way we could write the remainder is we could put plus 1 over 7. That's the fraction that remains. 1/7 remains. So this is one way that we could write our answer. Let's go ahead and do long division of polynomials. So we're going to set this problem up the same way. Now, let me just tell you that it's helpful to have a second color red pen or a different colored pen when we do these problems. Okay, so the first thing we want to do is we're going to multiply, and we need to multiply x squared by something to get x cubed. Well, what do we multiply x squared by to get x cubed? Well, just x. I'm going to write this above the 2x because I want to leave the same degrees kind of lined up. And you learned in a previous video that the degree means exponent. Okay, so I'm going to now multiply. Just like I did over in this first problem we did, we multiplied that 8 times the 7. I'm going to multiply here and distribute that x to each of these terms. So distributing the x times x squared gives me x cubed. Distributing again, I get negative 3x squared. And then finally distributing, I get a plus 5x. Now we're going to subtract. But subtracting negative and positive integers is a little tricky. So what I'm going to do is I'm going to change my color here. And I'm going to change all of these signs on the bottom polynomial to their opposites. The reason I'm doing that is instead of subtracting, we're going to add the opposites. That just makes the mental math a little bit easier to do. So x cubed plus negative x cubed, those just cancel out. I'm not going to write anything. We have a negative x squared plus 3x squared. So when I add that next column, I get 2x squared. Adding again, 2x and negative 5x gives me negative 3x. Just like we did on the problem on the left, we're going to bring down that next term. So I'm bringing down that negative 1. Okay, let's take a look here. I need 2x squared. And I have an x squared. So how many times do I multiply x squared to get 2x squared? Well, I'm going to multiply it twice. So I'm going to put a plus 2 here. Okay, let's change the color so we can distribute more easily. So I'm going to distribute the 2 now to each of these terms again. You do not need to draw these arrows when you go ahead and do your problems. Okay, so distributing the 2, we're going to get 2x squared minus 6x plus 10. Remember, we're going to change to a different color, and we're going to change the signs in that bottom polynomial to their opposites. So changing each sign to the opposite, and now we add, because adding the opposite is the same as subtracting. So adding those first 2 terms, they just cancel out. We can cancel them out. The next 2, adding them, we get 3x, and then adding the constants, we get negative 11. This is our remainder because the 3x is now smaller than the x squared. So I can't do any more division. So we're going to write the remainder. We're going to put a plus sign always. Put the remainder over what we divided by. It's called the divisor. We're going to put the remainder over the divisor. So this is all the answer to our division problem. Okay, so it might be helpful to put in your notes that adding the opposite is the same as subtracting. Just important little concept in algebra. Adding the opposite, same as subtracting. Okay, we're going to do this again. Same concept, slightly different example. So let's take a look. Okay, we're going to divide this big polynomial by 2x minus 5. Now, if you notice, in the polynomial we're starting with, we're missing an x cubed term. So when we write this polynomial out, we're going to put a 0x cubed. We kind of need a 0x cubed there as a placeholder, so we don't miss out on any powers. So I'm going to put a 0x cubed here and copy the rest as is. Okay, dividing by 2x minus 5. Make sure you're writing all these problems down and paying attention to the video. So now we're going to divide. What do I have to multiply 2x by to get 8x to the 4th? Well, I multiply by 4. I have to multiply by 4x cubed because x times x cubed would give me x to the 4th. Okay, let's distribute. So distributing again over here, I'm going to get 8x to the 4th minus 20x cubed. Okay, I'm going to change the signs so I can add the opposites. So adding the opposites, that cancels out. We have 20x cubed minus 52x squared. Okay, multiplying 2x by something to get 20x cubed. What do we multiply 2x by to get 20x cubed? We need a 10 for sure. And then x squared times x would give the x cubed that we want. Go ahead and distribute. When we distribute, we get 20x cubed minus 50x squared. Change the color, change the signs to their opposite, and now we add. So adding, we get negative 2x squared plus 7x. What do we multiply 2x by to get negative 2x squared? Well, we need a negative for sure. And we need one more power of x, so we just multiply by negative x. Distribute the negative x through. Sorry, the cat's serenading us in the background here. Okay, changing the signs to the opposite color again. And adding. And it looks like when we do that, we're left with a 2x. Bring down that minus 5. Well, how many times does 2x go into 2x? One time. So we multiply 2x minus 5. That would, if we subtract something from itself, it would give us a remainder of 0. So this polynomial on top of the division symbol is the answer. This has no remainder. Okay, this next problem is very similar to your performance task this week. The performance task isn't going to open up until Wednesday morning, but you're going to have a problem like this that you need to solve and then write out a description of how you solved it. And I'm going to assign you a different problem based on the first letter of your last name. So make sure you're doing your own work. See me in office hours if you need help. Okay, so this problem says this first polynomial divided by the second polynomial equals this answer for what value of b? So there's a constant b in this problem. We need to figure out what value of b would make the problem give the answer on the right. So we're going to start this off just by doing long division like we did on the two previous screens. So I'm going to leave that b there. That might be a little bit awkward for y'all, but that's okay. It's going to help us get to what we want. Let's divide that by x squared minus x minus 1. Let's go ahead and start our dividing. So I need to multiply x squared by something to get x cubed. X squared times x is going to give us x cubed. So multiplying x times x squared gives us x cubed. Distributing the x again to the negative x, which gives us negative x squared. And distributing one more time, minus x. Okay, let's change the signs to their opposite. So when I've had students do these problems in the past, the biggest place people make mistakes is just getting their signs wrong. So I highly recommend doing the other color and just being careful as you go through this. This is a skill that you need for pre-cal next year. So make sure you take this lesson seriously. I know it's really hard to lose focus and give up this time of year, but keep working hard. Hey, it's a Saturday afternoon and I'm recording this video because sometimes I have to work 6 days a week to get all my work done. So if I'm working this hard, you can do it too. You are awesome. Keep working hard. So let's add the opposites here. The x cubes cancel. Adding the next terms, we get 3x squared plus 2x, and let's bring down that b. Okay, now we're dividing, so we need something times x squared to give 3x squared, so we're just multiplying by 3. This looks good because it's matching the answer at the top of the page so far, so that looks good. Okay, so distributing, we get 3x squared minus 3x minus 3. Again, carefully changing the signs to their opposite. And then adding, we get 5x plus b plus 3. Okay, so let's see. If I were to write the answer to this division problem, I would get x plus 3 plus, always do a plus sign before the remainder. We're going to put the remainder on top. Oh, there's the cat. We're going to put the remainder over what we divided by. Okay, so now let's compare that answer to the answer above here. And I'm going to pause this and get rid of that cat. Okay, so comparing the answer we got with the answer above, it looks like everything matches, which is ideal. And we're just going to use the two numerators here to solve for b. So it should be pretty easy. So let's just set those equal. So we're going to have 5x plus b plus 3 equals 5x plus 1. Let's subtract the 5x out of both sides. So subtracting 5x, that goes away. So we have b plus 3 is equal to 1, and so b is equal to negative 2. So expect your performance task this week to look like a problem like this, okay? So if you need help solving it, for sure, join me in office hours and I'll walk through how to do this problem with you. Just make sure you're keeping it honest and not cheating on anything. Okay, that's long division. There's another method called synthetic division. Synthetic division is easier, but it doesn't always work. So we have to learn long division. Even though it's a more cumbersome method, it works for all polynomials. Synthetic division would not work on this problem. See our divisor, the thing we divided by at the top of the page that I boxed in red, it's a quadratic. For synthetic division, our divisor can only be a linear. Okay, let's look at the synthetic division problem. So the reason we can use synthetic division on this problem is because our divisor is a linear. So back here, this is a linear divisor. It's a linear function. There's no powers of x other than 1 or 0. It also has a leading coefficient equal to 1. So the kind of synthetic division that I'm going to show you only works when we have a linear divisor and a leading coefficient equal to 1. So you still need to know long division for problems like the first 3 that we did. So here's how we set up the synthetic division. So we're going to draw this little thing. I call it a shelf. And what we're going to do there is we're going to take this 2 and put it on the shelf, but we're going to change the sign. So you're going to change the sign on that constant in the divisor and put it on the shelf. Then going across, we're going to make a little row here of the coefficients. So we're going to bring the coefficients of this cubic function down and write them going across. So the coefficient of the x cubed is 1. The x squared has a coefficient of -2, and then 8, and then -14. Let's leave some space, and then we're going to draw a horizontal line. Here's how we do the synthetic division. First thing we're going to do is we're just going to bring that 1 straight down. Then I take the 1 and the -2, and I multiply those. So 1 times -2 gives me -2. Now I'm going to take these 2 and I'm going to add them. So I'm going to go down here and add the -2 and -2, which gives me -4. What do we do next with the -2 and the -4? We multiply those. So just like we multiplied at the beginning, we multiply those and we're going to get an 8. What do we do with the 8 and the 8? We add. And then lastly, what do we do with the 16 and the -2? We multiply. And 16 times -2 is -32. And then lastly, we add, and that gives us -46. This is our remainder. There's a lot less writing with synthetic division. You're just dealing with the coefficients. You can not have to worry about writing the variables and exponents down. It just simplifies it a little bit. So what did we do? Well, let's look at the original problem. We divided x cubed by x. So if we divide x cubed by x, what's the biggest power that's going to be left in our answer? X squared. So this tells me in the answer I have 1x squared. Then I bring down the -4, so that's -4x. I have plus 16 next in my answer. And then just like with the long division, we're going to write the remainder over the divisor. So go back to the original problem. What did we divide it by? We divided by x plus 2. So this is how you complete a problem using synthetic division. Okay, one more. Wow, would you take a look at that one? Mighty fine. Okay, so just like before, you're going to take that -2 and you're going to put it on the shelf but change the sign on it. So this time the -2 becomes a +2. Let's write our coefficients down. I don't think we're missing any powers of x. 5, 4, 3, 2, 1. Yeah, we're not missing any powers of x. If we were, we would put a 0. Just like we put a 0 when we were doing our long division, if we were missing a power of x. So before you start, just double check to make sure your signs are all correct. And let's commence. Bringing the -8 straight down. What do we do with these two? We multiply. And then add -18. Multiplying with the 2 and the -18 gives us -36. And then adding. Keep going. Okay. Just checking my work here. I think it's good. Okay. So recall, in the original problem, we divided an x to the 5th by an x. So what's the biggest power in our answer? It's going to be x to the 4th. So we're going to start counting down. Negative x to the 4th, 8x to the 4th, minus 18x cubed. Wow, all negative signs there. Minus 6x squared, minus 14x, minus 23, and then remember that negative 50 is a remainder. You always put a plus sign before the remainder. Remainder of negative 50 over the divisor, x minus 2. Okay? Make sure that you write a really good summary for me and upload a photo of this to Canvas. I hope you're doing well. Let me know if you need help with anything. Okay, take care.